Waves, they are a mesmerizing dance of energy, constantly shaping and reshaping coastlines. But what exactly causes these rhythmic undulations on the ocean surface? The answer lies in the wind. As wind blows across the water's surface, friction creates small ripples. These ripples are then amplified by the continued force of the wind, growing in size and strength. The stronger the wind, the larger the wave. The distance the wind blows over water is called fetch. A longer fetch allows the wind to transfer more energy to the water, resulting in larger waves. The duration of the wind is also crucial. A steady wind blowing for a longer period will generate larger, more powerful waves. We can classify waves into three main types. Wind waves are the most common, generated by local winds. Swell waves are larger, more evenly spaced waves that have traveled long distances from their origin. Finally, tsunamis are giant waves caused by underwater earthquakes or volcanic eruptions. Twice a day, like clockwork, the ocean level rises and falls. This rhythmic ebb and flow, known as tides, are a testament to the invisible forces at play in our universe. The primary driver of these tides is the gravitational pull of the moon. The moon's gravity pulls the water on the side of Earth closest to it, creating a bulge. A corresponding bulge occurs on the opposite side of Earth due to inertia. As the Earth rotates, these bulges travel across the planet, causing high tides. Low tides occur in the areas between these bulges. The sun also exerts a gravitational pull on Earth's oceans, although it is weaker than the moon's influence. When the sun, moon and Earth align, their combined gravitational forces create exceptionally high tides, known as spring tides. Conversely, when the sun and moon are at right angles to each other, their gravitational forces partially cancel out, resulting in lower high tides called neap tides. Sea level refers to the average height of the ocean's surface. This measurement is crucial for understanding various environmental and climatic phenomena. It serves as a baseline for mapping and navigation, and is a key indicator of climate change. However, this level is not static. It is constantly changing, influenced by a myriad of factors that operate on different timescales and magnitudes. It fluctuates over time due to a complex interplay of factors, some occurring over short periods and others over millennia. These fluctuations can be observed in daily tidal changes, seasonal variations, and long-term trends spanning centuries. Tides, as we've learned, cause regular short-term fluctuations in sea level. These are driven by the gravitational pull of the moon and the sun, creating predictable patterns of high and low tides. Storm surges caused by low atmospheric pressure and strong winds during storms can also lead to temporary but significant rises in local sea levels. These surges can result in devastating coastal flooding, especially when combined with high tides. Long-term factors play a crucial role in shaping global sea levels. These include processes such as thermal expansion, melting ice caps, and tectonic activity, which can cause gradual but significant changes over decades to millennia. Thermal expansion, the tendency of water to expand as it warms, is a major contributor to rising sea levels. As the ocean absorbs heat from the atmosphere, its volume increases, leading to higher sea levels. As global temperatures rise due to climate change, the ocean absorbs vast amounts of heat, causing its volume to increase. This process is exacerbated by the increasing concentration of greenhouse gases in the atmosphere. Melting glaciers and ice caps are another significant contributor to rising sea levels. These massive ice bodies store vast amounts of fresh water, and their accelerated melting adds to the ocean's volume. As global temperatures rise, glaciers and ice caps melt at an accelerated rate, adding vast quantities of fresh water to the ocean. This not only raises sea levels, but also affects ocean salinity and circulation patterns. Lastly, tectonic activity, the movement of Earth's tectonic plates, can cause both rises and falls in sea levels over geological timescales. This includes processes such as volcanic activity, earthquakes, and the gradual shifting of land masses, which can alter the shape and volume of ocean basins. Waves, tides, and sea levels are not just fascinating natural phenomena. They play a vital role in shaping our planet and supporting life as we know it. Waves are essential for marine ecosystems. They oxygenate the water, stir up nutrients from the seabed, and create habitats for a diverse array of marine life. Tides, with their rhythmic ebb and flow, create unique intertidal zones home to specialized plants and animals adapted to life both submerged and exposed to air. Coastal communities rely on waves, tides, and sea levels for various reasons. Fishing, transportation, and tourism are just a few examples of industries that depend on these oceanic forces. Sea levels also determine the location and vulnerability of coastal settlements, impacting infrastructure and human populations. Furthermore, waves and tides hold immense potential for renewable energy generation. Wave energy converters harness the kinetic energy of waves to generate electricity. Similarly, tidal power plants utilize the predictable rise and fall of tides to generate clean energy. Climate change, driven by human activities that release greenhouse gases into the atmosphere, is having a profound impact on our oceans, affecting waves, tides, and sea levels in concerning ways. The burning of fossil fuels, deforestation, and various industrial processes have significantly increased the concentration of carbon dioxide and other greenhouse gases in the atmosphere. This has led to a warming effect, commonly known as global warming, which is causing dramatic changes in our climate systems. Our oceans, which cover more than 70% of the Earth's surface, are particularly vulnerable to these changes. They absorb a significant amount of the heat trapped by greenhouse gases, leading to a series of cascading effects that are reshaping marine environments and coastal regions. The most significant consequence is the accelerated rise in sea levels. This phenomenon is primarily driven by two factors: the thermal expansion of seawater as it warms and the melting of ice from glaciers and polar ice caps. As the temperature of the ocean increases, the water expands, taking up more space and causing sea levels to rise. Simultaneously, the melting of ice on land adds more water to the oceans, further exacerbating the problem. As global temperatures continue to climb, thermal expansion and the melting of glaciers and ice caps contribute to higher sea levels at an alarming rate. This rise in sea levels is not uniform across the globe. Some regions experience more significant increases than others due to factors such as ocean currents, wind patterns, and the gravitational effects of ice mass loss. The consequences of these rising sea levels are far-reaching and multifaceted. This rise poses a severe threat to coastal communities worldwide. Many of these communities are already experiencing the impacts of higher sea levels, including increased flooding during high tides and storm surges. Coastal infrastructure, such as homes, roads, and bridges, is at greater risk of damage or destruction. In some cases, entire communities may need to relocate to higher ground, leading to social and economic challenges. Rising sea levels increase the risk of flooding, erosion, and saltwater intrusion into freshwater sources. Flooding can lead to the displacement of people, loss of property, and significant economic costs. Erosion, which is the gradual wearing away of land by water, wind, and other natural forces, can result in the loss of valuable land and habitats. Saltwater intrusion occurs when seawater encroaches into freshwater aquifers, contaminating drinking water supplies and affecting agricultural productivity. Coastal erosion can lead to the loss of valuable land, infrastructure, and ecosystems. The natural barriers that protect coastlines, such as dunes and wetlands, are being eroded away, leaving areas more vulnerable to the impacts of storms and rising seas. This loss of protective barriers can result in more severe and frequent flooding, further endangering coastal communities and ecosystems. Saltwater intrusion threatens agriculture, drinking water supplies, and the delicate balance of coastal ecosystems. Crops that rely on freshwater irrigation can be damaged or destroyed by saltwater. leading to reduced agricultural yields and food security issues. Additionally, the intrusion of saltwater into freshwater habitats can disrupt the balance of ecosystems, affecting the plants and animals that depend on these environments. Furthermore, climate change also influences wave patterns. Changes in wind patterns and intensity due to climate change can lead to more frequent and intense storms, generating larger and more destructive waves. These changes in wave patterns can have significant implications for coastal erosion, marine navigation, and the safety of coastal communities. Changes in wind patterns and intensity due to climate change can lead to more frequent and intense storms, generating larger and more destructive waves. These powerful waves can cause significant damage to coastal infrastructure, erode beaches, and pose a threat to marine vessels. The increased frequency and intensity of storms also heighten the risk of storm surges, which can lead to catastrophic flooding in coastal areas. These changes have implications for coastal erosion, marine navigation, and the safety of coastal communities. As wave patterns shift and storms become more intense, the challenges faced by those living and working in coastal areas will continue to grow. It is crucial for communities to adapt to these changes through improved coastal management, infrastructure planning, and disaster preparedness to mitigate the impacts of climate change on our seas and shores. The challenges posed by climate change and its impact on our oceans are daunting, but not insurmountable. The melting ice caps and rising sea levels are stark reminders of the urgency of the situation. Coastal communities are already feeling the effects, with increased flooding and erosion threatening homes and livelihoods. Taking decisive action now is crucial to mitigate these risks and protect our planet for future generations. Community-driven initiatives like beach cleanups and environmental activism play a vital role in raising awareness and driving change. Every small action contributes to a larger movement towards sustainability. The most critical step is to address the root cause of climate change, reducing greenhouse gas emissions. Industrial activities and urbanization have significantly increased the concentration of these gases in our atmosphere, leading to global warming and its associated impacts. Transitioning to a low-carbon economy by investing in renewable energy sources such as wind, solar, and tidal energy is essential. These technologies not only reduce our carbon footprint, but also create new economic opportunities and jobs in the green energy sector. Improving energy efficiency and promoting sustainable transportation is essential. Electric vehicles, public transit, and bike lanes reduce our reliance on fossil fuels and decrease air pollution, contributing to healthier urban environments. Protecting coastal barriers, such as mangroves, is another crucial strategy. Mangroves act as natural buffers against storm surges and rising sea levels, while also providing habitat for diverse marine life. Their roots stabilize the shoreline, preventing erosion and maintaining water quality. Salt marshes and coral reefs also play vital roles in coastal protection. These ecosystems absorb wave energy, reducing the impact of storms and preventing coastal erosion. Additionally, they support biodiversity and contribute to the overall health of our oceans. These natural barriers act as buffers, absorbing wave energy and protecting coastlines from erosion. By preserving and restoring these ecosystems, we can enhance their ability to shield coastal areas from the adverse effects of climate change. Investing in their restoration and conservation is vital. Restoration projects not only rebuild these critical habitats, but also engage local communities in conservation efforts, fostering a sense of stewardship and responsibility towards the environment. Supporting the development and implementation of renewable energy technologies, particularly those harnessing the power of waves and tides, can provide clean energy solutions while reducing our reliance on fossil fuels. These innovative technologies have the potential to revolutionize our energy systems and significantly cut down greenhouse gas emissions. Ocean-based wind farms and wave energy power plants are examples of how we can utilize the vast energy potential of our oceans. These projects not only generate renewable energy but also create jobs and stimulate economic growth in coastal regions. This shift to renewable energy sources is critical for mitigating climate change and its cascading effects on our oceans. By reducing our dependence on fossil fuels, we can decrease the rate of global warming and protect marine ecosystems from further harm. By understanding the interconnectedness of waves, tides, and sea levels, we can better predict and prepare for the impacts of climate change. This knowledge allows us to develop more effective strategies for coastal management and disaster preparedness. And the impact of human activities on these delicate balances, we can make informed decisions and take meaningful actions to protect our oceans, our planet, and ultimately ourselves. Collaboration between scientists, policymakers, and communities is essential to drive the changes needed for a sustainable future.